Hello everyone. In these sessions, I'd like to introduce one more important circuit element, diode. In the case of the ohmic resistors, current and the voltage is proportional with each others. I is equal 1 over R times voltage. The slope of this line is expressed 1 over R. In the case of the semiconductor diode, current is not proportional to the voltage. When the voltage is the positive quantities, current is increasing. But when the voltage is negative quantities, very small amount of the current is flowing. The current is flowing in only the one directions. So one-way current is permitted in the diode. To describe the diode with these symbols or these ones, current is flowing from the anode to the cathode. So to remember these symbols, you can considering the anode is starting from the alphabet of A. This looks like a A. So this is anode to the cathode. Okay, this is the diode. But if you consider the single diode is in a circuit, alternating current and one resistor and diode connecting in the series connections. A diode permits only one-way current, but in the case of the alternating current, voltage becomes positive quantities or negative quantities. If the diode is in the circuit, diode permits only one-way current. We could observe positive voltage. Then negative input is removed. So how can we recover the removed negative input voltage using the diode? If we combine the 4 diodes, we can solve the problems. So this is the answer to these questions. When the current is flowing in these directions, current is flowing. Then among the 4 diodes, the current is flowing in these directions. Flowing in these directions and pass through the resistor. And this is the one-way current. It's permitted and return to these directions. And then return to the AC. This is the case of the current is flowing upward. When the current is flowing downward directions, then take another diode, this one, and again flowing the current downward in this resistor and passing through the diode and coming to this point, and take another diode, this diode, and return to the AC. If we use 4 combined diode, input is positive and negative positive, but output always we have positive quantities by combining the 4 diodes. This is the full waves rectifications. In this situation, sometimes the voltage is dropped to the 0. So at this point, voltage becomes 0. We introduce a capacitors in a circuit. Then voltage does not decrease to 0 due to the capacitors because the capacitors keep some charges on the plate. So charge on the plate. This charge is going to flow to the resistor and the diode. And then it cannot go to the 0. Instead, it's come to some finite quantities. Then it looks like a direct current. We need to introduce one more element. Is inductors. Inductor is introduced in this circuit. By introducing inductors, sudden change of voltage is prevented. So sudden change of the voltage is prevented, and finally output becomes constant voltage. So in a laptop computers, we use converters, AC to the DC converters. So from this to here is AC to the DC. AC to DC converters is this circuit. inside. Okay, I explained how AC to DC converter works. Next topic is the transformers. High voltage is desirable for long distance transmissions to reduce dissipations in the transmission lines. Transformers are used to convert voltage. So near our house, we use a transformer to convert from the high voltage to the low voltage. So I'd like to explain what's happened in transformers. Symbol for the transformer is this one, because the transformer uses two coils. One of the coil has a N sub 1 turns. The other coil has a N sub 2 turns. And I'd like to explain how to transform the high voltage to the low voltage or low voltage to the high voltage. So alternating current in a primary, this is a primary, set up the alternating magnetic flux in the coils. So by flowing the current in the coils, produce a magnetic flux in the coils. This magnetic flux also pass through this secondary. EMF is induced in the secondary coils. So we'd like to find out the induced EMF using the Faraday's laws. So E sub 1 is expressed minus N sub 1 is N sub 1 turns times derivative of the magnetic flux with respect to times. And E sub 2 is a minus N sub 2 times the time derivative of the magnetic flux. This magnetic flux is the same for the both coils. So if you take a ratio of these two, E sub 2 over E sub 1, it becomes N sub 2 over N sub 1. So if you consider the N sub 2 is larger than N sub 1, N sub 2 over N sub 1 is larger than 1. So you can substitute these quantities here. So this means epsilon sub 2 over epsilon sub 1 is larger than 1. So this means epsilon sub 2 is larger than epsilon sub 1. We call that this is step-up transformers because the voltage becomes increasing using the transformers. If you consider the N sub 2 is smaller than the N sub 1, epsilon sub 2 is smaller than the epsilon sub 1. Voltage is decreasing. For your laptop computers, we use this type of the transformers. In today's sessions, I explained the two important applications of the electromagnetism. First one is the AC to DC converters. Second one is the transformers. This is the end of today's session.